Problem number 22 is really about empirical and molecular formulas and their differences and similarities. So keep in mind that empirical formulas are formulas that are always in the lowest whole number ratio. For example, ionic compounds, they are always in the lowest whole number ratio. Sodium chloride, NaCl, is an ionic compound, always in the lowest whole number ratio. Molecular compounds are usually shown in their actual composition. So we don't often encounter molecular compounds in their empirical formula lowest whole number ratio. However, there are some relationships between empirical formulas and molecular formulas that are useful to understand when you're trying to determine the molecular formula from the empirical formula of a compound. So, for example, you might have do some research with a chemical and find out that its percent composition information tells you that the ratio of carbon to hydrogen to oxygen in the compound is 1 carbon to 2 hydrogens to 1 oxygen. And you might do some other research that tells you the molar mass of this compound is 180 grams per mole. And you would discover that if you find the molar mass of this empirical formula, if we add a carbon and 2 hydrogens and an oxygen together, we're going to get an empirical formula mass of about 30 grams per mole. Now, what we can try here is this. We know that the molecular formula of this compound that we're working with is really not the same as this empirical formula. It's really multiplied by some factor that is the same factor we would multiply to get from 30 to 180. So if we take 180 and divide it by 30, we should get a small whole number ratio. Now this small whole number ratio, let's see, 18 divided by 3 is a 6. So we know that this empirical formula, if we multiply it by a factor of 6, in other words, we do C6H12O6, we multiply that by a factor of 6, and sure enough, we get 180 grams per mole if we take time to find its molecular mass. So often when we're finding these relationships between molecular and empirical formulas, these are the kind of steps we take. So when are empirical and, when are the empirical formula mass and the molar mass the same? Well, they are the same if the molecular mass, the molecular formula is in the lowest whole number ratio. That's when they are the same. And they are different if the molecular formula is larger than the empirical formula, and it would be larger by some factor, whole number factor usually. And how are molar mass related to empirical formula mass? Well, molar mass is, if you take the molar mass and multiply it by some small whole number, you will get the molecular formula mass. And that ratio of empirical formula mass to molecular formula mass also gives you the ratio of the empirical formula to the molecular formula.